So yeah, as you will have guessed from the title of the department where I work, my work and the work of most of my colleagues is quite interdisciplinary, and in particular, most of my work is at the intersection of philosophy and economics. And I've been particularly interested in the nature of attitudes to risk and some of the moral and political consequences of people having different kinds of attitudes to risk. And so this paper is sort of part of a foray into an application of some of the themes of my work to AI governance. And it's called Risk Imposition by Artificial Agents, the Moral Proxy Problem. It's probably more like 45 minutes than half an hour, but I'll try and keep brief. So the kinds of artificial agents that I'm interested in is ones that have some autonomy, so they make decisions without continuous human input, but they fall short of having full moral agency in their own rights. So things like self-driving cars or artificial trading agents or nurse bots. And in particular, the problem that I want to raise is one that is especially important in cases where, in the absence of the introduction of these artificial agents, decision-making is quite decentralized, such as the case with human drivers, and then the introduction of self-driving cars into a context where there were mostly human drivers. And the ambition with these kinds of artificial agents is to make decisions roughly as good or better than those that humans would make on behalf of humans, to serve human ends. So in the case of self-driving cars, that would be something like getting us to our destination efficiently and safely. And if they didn't do that at least as safely and efficiently as humans would make, there would be no point in introducing them. But the hope is that they can actually potentially do it more safely or more efficiently. And there's a design challenge that you're very familiar with, which is that many artificial agents will have to make morally difficult choices, or choices that might come with a potential of harm to humans. And in that sense, they might be moral proxies for human agents, that they make morally relevant choices on behalf of humans. And then the question is, how should they be designed to do so? So this is the familiar question of the moral design of these agents. And specifically, so my interest in recent work has been on risk. And so a specific question I'm interested in is, many of the choices artificial agents face are under conditions of uncertainty, including some of the morally relevant decisions that these agents make. So the question there is then, should they be programmed or trained to be risk neutral or not? And I'll explain in a moment what risk neutrality is and what it might mean to not be risk neutral. Now, what do I mean by the term the moral proxy problem? So this appears in the title of the paper. So I've just said these kinds of artificial agents that don't have full moral agency in their own right, we can see them as moral proxies. But for any morally significant choice and choice context that an artificial agent might face, we can ask, who should they be a moral proxy for? And often the answer to that question isn't all that clear. And a very sort of rough distinction that I think that can often be made between two kinds of answers to this question, and that is relevant for the problem that I want to raise in the following, is that between low-level agents and what I call high-level agents, where you can think of low-level agents as the kinds of agents that in the sort of decentralized decision-making context, such as human drivers in traffic, we can think of those as the low-level agents or the individual users of those self-driving cars, whereas high-level agents are those that are in a position to control the choices of many artificial agents, such as designers or regulators acting on society on behalf of society as a whole. And this question of who and what kind of agent artificial agents are moral proxies for has been discussed for the purposes of responsibility ascription. So I think this kind of question is fairly familiar from there. Is it the individual users that are responsible, in particular if something goes wrong, or is it high-level agents such as designers? But I'm interested in this question mainly for the purposes of decision structuring when making practical design choices. So when we make decisions about how artificial agents should be designed, we have to think about the kinds of choice contexts they might find themselves in, and in the broadest sense of the term, sort of adjust the decision-making of those artificial agents to what we think on reflection is the right way for them to behave in those decision contexts. In order to go through that exercise, we have to already sort of frame the decisions that we want them to make well in a certain kind of way. And that's the question of decision structuring. How should we structure those decisions in the first place? And I think the moral proxy problem comes up there already, because there's a question of from whose agential perspective we should be framing the relevant decision problems. Is it from the perspective of the kinds of low-level agents or individual users whose decision-making, in a sense, artificial agents are replacing, or is it from the perspective of a high-level agent, such as a designer or regulator who can control the choices of many artificial agents? And the thesis here is that in context of uncertainty, the moral proxy problem has practical relevance, and it has practical relevance stemming from this issue of decision structuring. And I'll argue that moral proxies for low-level agents may need to be risk-averse in individual choices that they face. And that's actually something that standard approaches in artificial agent design don't accommodate. Whereas moral proxies for high-level agents should be risk-neutral in individual choices, because this is almost certainly better outcomes in the aggregate. So I'll spend most of the talk trying to make this point of the practical relevance of agential perspective in decision structuring. And then in the end, I'll discuss how each way of addressing the problem comes with some sacrifices. So I think it's a hard problem. Okay, so I'll start with some notes on expected utility theory, which is the orthodox theory of choice under uncertainty used in various social sciences, in particular economics, which is part of what my background is. But it's also the theory that in the AI literature we often see appealed to as the theory of individual choice that eventually we try and approximate when we design artificial agents. Moral philosophers also often defer to it when it comes to conditions of uncertainty. So often we see in particular consequentialist ethicists, but also contractarians, for instance, just assume expected utility theory as the correct theory of individual choice when there's uncertainty. A very simple version of this is something like this. So we first think about the potential outcomes of an agent's choices. This is the X. We then assign a utility to each of these potential outcomes of an agent's choices, and also a probability with which the different outcomes are estimated to arise as the consequences of our choices. So then we can calculate an expected utility for each of the acts that is open to us, and expected utility theory says we should pick the act with maximum expected utility. So maximize the probability weighted sum of the utilities of different outcomes. So this is a simple version of expected utility theory. Now, there are two worries about the reliance on expected utility theory for the design of artificial agents. The first one I'll just mention here, and I'll bracket for the purposes of this talk. And that's that when risks of harm are imposed on other people, the application of expected utility theory implies that we're insensitive to how ex ante risks are distributed between people. But there might be a good reason stemming from fairness to try and distribute chances equally between people as well. But expected utility theory would be insensitive to that. So that's a problem that's sometimes been discussed. But a less discussed problem that I'm more interested in here is that expected utility theory is controversial because, at least under one common interpretation, which I think is the interpretation adopted in the AI literature as far as I've seen it, implies risk neutrality in the pursuit of goals and values and rules out pure risk aversion. And I'll explain in a moment what I mean by pure risk aversion. So roughly what risk aversion in the attainment of some good is it, or what it manifests is in choosing an option with a lower expectation of that good because the potential outcomes are less spread out. So a paradigmatic example of this would be choosing a sure £100 over a 50% chance of £300. So 50% chance of £300 has an expectation of £150, which is higher than 100, but a risk-averse agent might nevertheless choose £100 because the potential outcomes are less spread out. In this case, there's just one outcome, which is £100, so all the probabilities on that. So that's a paradigmatic example of risk aversion. And expected utility theory can capture risk aversion in the standard way. If you're familiar with economics, you will have seen this. The standard way in which expected utility theory can capture risk aversion is through decreasing marginal utility in the good. So the more you already have of the good, the less additional utility you get from an additional unit. So here's just an example that would illustrate the choice of £100 over a 50% chance of £300. In this case, you get a utility of 10 from the £100 for certain. 300 would give you 17.32 and 0 would give you 0. So the expected utility of the gamble is 8.66, which is less than 10. And what makes this possible is that the utility difference, the added utility you get by going from the 100 to the 300 is less than the added utility you get from going from 0 to 100. So decreasing marginal utility in a good is the standard way in which expected utility theory can capture risk aversion. Now, there's a big debate whether this can adequately capture ordinary risk aversion as we see it in human agents. And this depends in part in what we think utility actually is. So I've just sort of been using this word without explaining what I mean by the term utility. And there are two common understandings of what utility is. One we can call substantive, or sometimes it's called realist, where utility is taken to be a cardinal measure of degrees of goal satisfaction or value, where ratios of utility differences, they capture the degree to which you think a goal is important, or the degree to which you value different outcomes. So in the case of the monetary gamble we've just seen, what that would mean is that if the utility difference between £100 and £200 is smaller than the utility difference between 0 and £100, that means that the difference between £100 and £300 is less important to you. It adds less to the extent to which your goals are satisfied than going from 0 to 100. So on this understanding, utility is a cardinal measure of degrees of goal satisfaction. Now, on this interpretation, expected utility theory does not allow for what is often called pure risk aversion, which would be risk aversion with regard to goal satisfaction or value itself. So whatever utility is, you can't be risk averse with regard to utility. You always pick the thing that has the higher expected utility. And then if utility just is value or the extent to which you've achieved your goals, that would mean that expected utility theory requires you to be risk neutral with regard to goal satisfaction itself. So that's what's meant by pure risk neutrality. Whereas if someone was purely risk averse, they might be risk averse with regard to the attainment of value or goal satisfaction itself. And we'll see in a moment a potential example that might motivate that that's not something that we should rationally or morally rule out. Another prominent interpretation of what utility is that utility is just whatever represents an agent's preferences, provided that these preferences are consistent with the standard axioms of expected utility theory and one's favorite representation theorem. So if you've done some economics, you'll know the most famous one is the von Neumann-Morgenstern representation theorem, So in this interpretation, utility is just whatever represents an agent's preferences. We know that if preferences are consistent with these axioms, an agent may be represented as expected utility maximizing. On this interpretation, utility is just a sort of formal thing. It's whatever we assign when an agent's preferences are represented in this framework. And this does allow for pure risk aversion, because then it's not incoherent to say something like this agent has decreasing marginal utility in value itself, or in the degree of goal satisfaction itself. So these are two common understandings. But I think that, in fact, the substantive understanding of utility seems to be common both in the AI literature and also among the moral philosophers who defer to expected utility theory. So I think when moral philosophers talk about utility, they almost always have the substantive notion in mind. And I found the same in the AI literature as far as I've seen it, but I'd be interested to see if you know of exceptions to this. But economists, on the other hand, often have the kind of formal interpretation of what utility is. You just have to be consistent with the axioms. So the standard approach, as I understand it, is that you specify the goals that a system should pursue in an objective function that measures the degree to which the goals are satisfied. So a super simple example would be a nutritional assistant programmed for high caloric intake that would just have one goal. But of course, usually there would be multiple goals, and then the objective function needs to specify the relative importance of the different goals, such as the goals of a self-driving car, of reaching one's destination fast, using little fuel, avoiding accidents, and so on. So you specify the goals in an objective function, and then you design or you train the agent to maximize the expectation of that function. And in the Russell and Novick textbook, this is treated as really the definition of rationality, that a rational agent should select an action that is expected to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. So on my reading, that seems to implement expected utility theory on a substantive understanding of what utility is, maximizing the expectation of degree of goal satisfaction. And so there seems to be an implicit commitment to risk neutrality regarding goal satisfaction. And now coming back to why expected utility theory might then be a problematic thing to adopt for artificial agent design, risk aversion and risk inclination regarding goal satisfaction itself are intuitively neither always immoral or irrational for human agents. And in the recent literature in philosophical decision theory, that's something that is more and more accepted, that pure attitudes to risk that are not neutral shouldn't be rationally ruled out and also not morally ruled out. And I'll present two examples of this before explaining how this is relevant for the moral proxy problem, which is what I started out with. So a first case, and sort of bear with me, these are both highly stylized kinds of cases. In the first case, an artificial rescue coordination center has to decide between sending a rescue team to one of two fatal accidents involving several victims. And let's assume that we've sort of respecified the case in such a way that the objective function is that we hold all other factors fixed other than the number of lives saved. And so it seems plausible on moral grounds that the objective function should be linear in lives saved, which would be capturing the intuition that each life saved is equally valuable, at least as long as we hold all other morally relevant factors fixed. So that's our objective function, and then you have to decide between one accident where you save one person for sure and another accident where there's a 50% chance of saving nobody and a 50% chance of saving 3. So in this case, if this is the correct objective function, it should be linear in lives saved. Applying expected utility theory on the substantive understanding would just mean that we have to pick accident 2. It has a higher expectation of the number of lives saved. However, a risk-averse human agent might prefer sending the team to accident 1. For which reason? Well, in that case, we make sure at least that we save one person. We're not risking ending up saving nobody. And so the intuition that's discussed about cases like this in the philosophical literature, and I'd be interested to see if there are actual experimental philosophy experiments incorporating risk aversion in the discussion later on, or cases of risk in the discussion later on. But the hypothesis is that at least some human agents would prefer accident 1, which is the risk-averse option, and also that this is not obviously irrational or morally wrong. In fact, there's some moral theories that require us to be precautionary. And if you don't share that intuition, like you can change the numbers somewhat. That there's a 67% chance of saving nobody, sort of come closer and closer to the expectation. And as long as there's some case where you'd rather go with the safe option, rather than take the risk with a higher expectation, you would share the intuition that sometimes pure risk aversion is rationally permissible and not morally wrong. Another case illustrating a similar point, which is maybe a little bit closer to more mundane situations, is this one: a self-driving car is driving on the left lane of a dual carriageway. We're in the UK here. And we're approaching a person that's kind of stumbling on the side of the road. At the same time, a car with 2 passengers is approaching from behind on the right lane, and the car estimates that there's a small chance that the car behind is approaching fast enough to fatally crash into it should it change lane, and a small, albeit 3 times higher chance that the person on the side of the road could trip at the wrong time and consequently be fatally hit by the self-driving car should it not change lanes. And again, we're assuming we can hold all other things equal apart from the number of accidental killings. And again, it seems plausible to say, from a moral perspective, that each accidental killing is equally bad. And so an objective function should be linear in accidental killings. And suppose there are 2 choices: don't change lanes, which comes with a 0.3% chance of killing 1, where the expected number of fatalities is 0.003. And on the other hand, it could change lane, which comes with a 0.1% chance of killing 2, where the expected number of fatalities would be 0.002. So a smaller number of expected fatalities. Again, a risk-averse human agent might prefer, thinking about those numbers, not to change lanes. So the thought then here again would be, you don't want to risk the terrible outcome of killing 2 people. So not changing lane is the less risky kind of option, even though it comes with a higher number of expected fatalities. And again, the intuition that is that a lot of philosophical decision theorists share now, and I think that is quite plausible, especially if you make the numbers even smaller together, is that this is not obviously irrational or morally wrong, and that we find that kind of preference potentially in experiments.
I think there's a question by Victor.
Okay. Sure.
Yeah, very quickly, this just came to my mind. Isn't this somehow related to the Allais paradox?
So in the Allais paradox, you've got a set of preferences that together violate the axioms of expected utility theory. So I think those are more controversial than the cases that I've presented here. Because, I mean, I've only given kind of one preference, and one preference alone can't in itself be a violation of the axioms, and the kinds of choices that I've just given can be accommodated within expected utility theory on the kind of formal interpretation. They just cannot be accommodated if we think utility must be understood in this kind of substantive way. But there are those who actually want to move to a different formal framework and abandon expected utility theory move to something like a rank-dependent utility theory. And those are often people who also want to accommodate things like the LA preferences and say that even the LA preferences, even though they violate the sure thing principle, they are not irrational, and our decision theories should be accommodating them. So it's sort of, it's the same, so it's all sort of part of a critical discussion of standard expected utility theory, but in fact the cases that I've given are less controversial than the LA preferences.
Okay, thank you.
Okay, so what's the takeaway from these cases? They're quite stylized, of course. They were chosen to illustrate the intuitive permissibility of pure risk aversion. So that's because they feature a kind of uncontroversially linear objective or value function. These are cases where there's only sort of one thing morally that's at stake, and it's highly plausible that each life is worth exactly the same. And if we are in a situation where there's this uncontroversially linear objective function, but nevertheless we think risk aversion is permissible, then that shows that pure risk aversion, that would be a clear example of pure risk aversion being rationally permissible. Now, of course, most applications are going to feature more complex value functions that trade off various different concerns, like safety, mobility, environmental concerns, and so on, in more mundane kinds of situations. But the hope is that the sort of general lesson, if there's pure risk aversion in the simple case, that there would also be pure risk aversion in the more complex kinds of cases. It's just harder to kind of isolate in a thought experiment. Now, in the case of human agents, I think we tend to be permissive of a range of levels of risk aversion. And expected utility theory can accommodate this under the formal interpretation that I mentioned earlier, because it would allow for decreasing marginal utility and goal satisfaction. But it can also be accommodated in alternatives to expected utility theory, such as, for instance, Lara Bouchak's risk-weighted expected utility theory, which has been quite popular in the philosophical literature and builds on rank-dependent theories as economists have previously proposed them. Okay, so if artificial agents were programmed to always be risk neutral, this would mean that they act differently from how many human agents would permissibly act in the same kinds of circumstances. So this is the takeaway from these individual cases. Now, I also want us to consider the compound perspective. And this is to motivate us coming back to the moral proxy problem in a moment. So consider the following compound gambles. Firstly, you have to decide at once on 100 independent instances of the first case we looked at, the unavoidable, the artificial rescue center. Sorry, this mentions two different cases. It's case one, the artificial rescue coordination center. There's a safe option, or what we previously described as a safe option, where you save one person for sure. If you do that 100 times, the safe option chosen in the compound gamble would be saving 100 people for sure. Whereas if you go for the risky option in each of these 100 independent instances, the expected number of lives saved is 150. And in fact, the chance of saving fewer people than in the safe option is less than 0.5%. So you're almost certain to save more people if you go with the risky option on 100 independent instances. And consider at once deciding on 100,000 independent instances of the case two, that should be the changing lanes case. In the safe option, this would lead to a number of expected fatalities of 300, and the chance of there being fewer than 250 fatalities is about 0.1%, so very, very small. And the risky option 100,000 times would lead to an expected number of fatalities of 200, and the chance of more than 250 fatalities is around 0.7%. So what this shows is that you're almost certain to to have fewer fatalities if you go with the risky option on these 100,000 independent instances. And so I think in each of these cases, when we look at the compound perspective, it seems really unreasonable to choose what was the safe option when we looked at an individual instance. So from this kind of compound perspective, risk neutrality in each of the individual instances seems to be called for. So whereas beforehand, when we only looked at the individual instances, there was an intuitive plausibility to non-risk neutrality, and in particular pure risk aversion. When we look at the compound gamble, it seems like risk neutrality is the only reasonable response to these cases. So this takes us back then to the moral proxy problem, which, remember, the question was, in any morally significant choice context that an artificial agent might face, who should the artificial agent be a moral proxy for? And I distinguished between a kind of low-level response to this question, that it's that it should be a moral proxy for a low-level agent, and a high-level one, where when we look at things from the low-level perspective, we would structure the decision problem from the perspective of individual low-level agents, such as the users of self-driving cars. And here, from that agential perspective, the decision problems that are faced by these cars are just the kinds of decision problems that human drivers would have previously faced. So things like the kinds of one-off choice problems that we considered first. And the design implication, if we, in the broadest sense of the word, want to emulate considered human judgment about such cases, would be that this may require implementing risk aversion. It might be that the sort of average response to this kind of case is one that is not risk neutral. So emulating considered human judgment about such cases might require us to abandon this commitment to risk neutrality. Whereas if we give a kind of high-level response, that things should be structured from the agential perspective of a high-level agent, such as designers or regulators, then really the choice problems we should be considering is the kind of compound choice problem, because we're now at once deciding about the choices made by a large number of artificial agents. And so the design implication there then is that we should be emulating considered human judgment regarding such compound choices. How should all self-driving cars be dealing with such situations? And for large enough compound choices, this appears to require implementing risk neutrality, just because the number of independent gambles that is repeated becomes large enough. At some point, it becomes virtually certain that you're going to have a better outcome by implementing risk neutrality rather than risk aversion, for instance. And so what this shows then is that in the context of risk, the moral proxy problem is of practical relevance for design choice. Depending on how we structure the decisions for the purposes of making design choices, we might get different answers as to how artificial agents should be behaving in the context of risk. So this was the sort of the first main point I wanted to make. And as I said, I'll present a few considerations in favor of either the low-level or the high-level framing. But essentially, this is to illustrate that this is a hard choice. I think it's not obvious which way we should go. So when it comes to the low-level agential framing, where we're just looking at these sort of individual choice scenarios similar to choice scenarios that human agents might face, I think this is often simply presupposed. So I think, my impression of this is certainly the kind of decision structuring we see in the Moral Machine project, for instance. And it's a sort of natural, a natural way to go about it, I think. And I think it's also natural if one thinks that only low-level agents, such as users, for instance, are appropriate bearers of responsibility. Why is that? Because it seems like it would be unfair to hold agents responsible for choices that are not justifiable from their agential perspective. So because we implemented a sort of high-level agential perspective in decision structuring, we made the artificial agents risk neutral, but that's something that if we look at what that means on the ground in terms of how morally significant choices are made, is something that's not justifiable from the perspective of an individual user, then it would seem unfair to hold them responsible for the choices of such an artificial agent. The reason they are risk neutral would be that makes sense from the perspective of public safety, but it doesn't necessarily make sense from the perspective of individual choice. So it seems like it would be unfair to hold agents responsible for choices that are not justifiable from their agential perspective. So if one already thinks that responsibility lies with low-level agents, then I think that's also a plausible response to how decisions should be structured. And I think another potential argument for low-level agential framing appeals to this idea of liberal neutrality. So here the thought is that there's reasonable disagreement about cases like the ones we considered. I think we can certainly imagine some people going for the risk-neutral choice and some people going for the risk-averse choice. And it might be something that we can't, even with a lot of debate, achieve moral agreement about. And one prominent response to reasonable disagreement like that is the idea of liberal neutrality, that somehow the state or collective decision makers shouldn't take a side on morally contentious issues. And one potential way of implementing this is just sort of partitioning the moral space, like leaving such morally contentious decisions up to individuals themselves to make. And I think this kind of idea of partitioning the moral space in order to assure liberal neutrality might speak in favor of a low-level agential framing, together with an option of allowing users to choose different ethics settings, and in this case also including different risk settings on their artificial agents. So I think this might be another potential argument in favor of low-level agential framing. But and I think this is especially attractive when there's no standard collective action problem that's involved, like in the cases that we considered. So it can be sort of bad from the perspective of everybody to leave decisions up to individuals when that predictably leads to an outcome that everyone finds worse, because we find ourselves in a sort of collective prisoner's dilemma kind of situation. But in the cases that I looked at least, there's an independence in utilities and probabilities between the individual cases. So we're not actually facing a standard collective action problem. And so in cases where there's no collective action problem, this way of partitioning the moral space seems like a good way to try and ensure liberal neutrality. But there are also costs of the low-level agential framing, the most obvious one being that aggregate outcomes that are almost certainly worse are almost certainly worse than the expected consequences of the choices that seem reasonable from the high-level agential perspective. And I think that might be just an uncomfortable position for designers to be in. They might be making design choices that predictably have these almost certainly worse consequences in the aggregate. So this is, I think, an important cost. And in favor of the high-level agential framing, then we have to say whether it avoids these costs of low-level framing that we just mentioned. And I think it's also, so to make this connection again to responsibility ascription, it's also natural if one thinks that only high-level agents are the appropriate bearers of responsibility, because again, it seems like it would be unfair to hold these high-level agents responsible for choices that are not justifiable from their agential perspective, like holding them responsible for the fact that there are almost certainly going to be higher numbers of deaths if we implement risk non-neutrality, and that risk non-neutrality is justified from the perspective of low-level agents. So it'd be unfair to hold high-level agents responsible for choices that are only justifiable from the low level. And so if one already independently thinks that high-level agents are the appropriate bearers of responsibility, that seems to speak in favor of high-level agential framing. So then we can look to arguments in favor of high-level responsibility, such as, for instance, sometimes arguments for moral luck that are made, so that so the idea here is that it's to some extent a matter of luck whether you ever find yourself in a situation where your self-driving car has to make these morally difficult choices, and whether you end up in the worst outcome in a case involving risk is again a matter of luck. And it seems bad to hold people responsible for bad outcomes where other people made exactly the same choices, but they were just lucky. And that seems to be, that's sometimes used then as an argument for holding the collective of all the owners of self-driving cars that are programmed in a certain way responsible as a collective. And so that might be an argument for going to the high level for responsibility ascription, which then could be an argument to frame decisions from that perspective in the first place. But the costs of high-level agential framing, I think, are that it, especially in the kinds of cases where previous to the introduction of artificial agents, decision-making is really decentralized, what this does is it introduces high-level control, be it by governments or by tech companies, in areas where previously decision-making by humans has been decentralized, and also in ways that don't simply reproduce what individual humans would have chosen for themselves, or even would have ideally chosen for themselves if they had time to reflect on the choice. And I think in this sense, the high-level solution involves a significant kind of restructuring of our moral landscape. So I think this is potentially a cost, or at least something we have to be aware of, how it sort of transforms, how it introduces more centralized control than there previously was, especially in those kinds of social contexts. Now, finally, I just wanted to mention how the moral proxy problem, I think, also raises a difficulty for a view that you quite often see expressed, namely that there's kind of shared or distributed responsibility for the choices of artificial agents between high-level and low-level views. So I think this is a popular view in debates about responsibility ascription for the choices of artificial agents, that somehow the responsibility is distributed between a number of different kinds of agents. But for the purposes, at least of decision structuring, we do need to decide one way or the other. We have to sort of settle on a way of framing, structuring the kinds of decisions that we see artificial agents as making in order to match them to considered human judgment. And we can't, so we have to do that first before we then consult our intuitions about it. And depending on which way we settle it, these intuitions might be different. So that's the way in which the moral proxy problem is practically relevant. And whichever we choose here, one group of agents might complain about being held partly responsible for design choices that were not justifiable from their agential perspective. So individual agents might say, well, this self-driving car is sort of, it's driving in ways that I don't find justifiable, and that only makes sense from the perspective of public safety. Or the other way around, a high-level agent might say, well, this self-driving car is risk-averse, which makes sense from the perspective of individual users, but from my perspective, this comes with predictably higher numbers of deaths, and it's unfair to hold me responsible for that. So in summary then, in context of uncertainty, what I aim to argue is that the moral proxy problem has practical relevance, that moral proxies for low-level agents may need to be risk-averse in the individual choices they face, which is something that standard approaches in artificial agent design don't seem to accommodate. And moral proxies for high-level agents should be risk-neutral in individual choices, because this is almost certainly better, or has almost certainly better outcomes in the aggregate. And I think each way of addressing the problem comes with some sacrifices, and my own mind is not entirely made up about which one is the better way to go. And I look forward to your views on this and the discussion. Thank you. Yes, some references.
Thank you so much. Fantastic.